All right, as I talk through these notes for dividing fractions, the homework that's listed here was from last year, so you can just ignore that. Your homework is 6 problems in Google Forms that you'll have to do. So the bell ringer from last year was just a review from the lesson earlier. So you can look at the numerator, 2m cubed minus 18m. There's a GCF there of a 2m that comes out. So that turns into 2m and parentheses m squared minus 9. The bottom, 5m minus 15, also has a GCF of 5. So you can bring that in the front with an m minus 3 left. The m squared minus 9, I have that highlighted because it's a difference of squares. So that factors into m minus 3 and m plus 3. So then you can see the numerator and denominator both have an m minus 3 factor that can divide out. So the final answer here is 2m, m plus 3 in parentheses, all over a 5. So keep in mind when we learn to divide normal fractions, you think of 3 words: keep, change, flip, or multiplying by the reciprocal of the second fraction. So you can see here, if I have 3/8 divided by 2/7, I can rewrite that as 3/8 times the reciprocal, which is 7/2, and then you can multiply straight across if needed. So that's kind of the idea we're going to do now, just make it a little more complicated with some variables mixed in. So if we look at this first one, 4 over 15n cubed divided by 12 over 25n. So it's really important on these to just rewrite the problem, keep the first fraction as is, change division to multiplication, take the reciprocal of the second fraction. So you can see I rewrote that in red. And then it's kind of what you did from the previous day. So look on diagonals to simplify, or you can multiply straight across first and then reduce. But I chose to look at the 4 and the 12 on the first diagonal, and they can be divisible by 4, so it turns into 1 and a 3. On the other diagonal, the coefficients are 15 and 25, both divisible by 5, so the 15 turns into a 3, 25 turns into a 5. And then if you look at your variables, you have 1 n at the top, 3 n's down below for n cubed. So you can cancel one of them out. So there's only 2 n's at the bottom, so that's n squared. And then multiply straight across with your coefficients. 1 times 5 is 5, 3 times 3 is 9. So 5 over 9n squared is your final answer there. Find each quotient. Remember, if you see the word quotient, it means to divide. So again, multiply by the reciprocal. So I can put that x minus 3 over 1 to start off with, so that when I take the reciprocal, I know the numerator has to become a 1. The 2x minus 6, I highlighted that because it has a GCF of a 2. So I can divide a 2 out of that. So it's 2x plus 3 over x squared multiplied by 1 over x plus 3. And like we learned in a previous lesson, the x plus 3 factors divide out. So you just have a 2 times 1, which is a 2 for your numerator, and an x squared underneath. So looking on the right side here, again, rewrite the problem. Multiply by the reciprocal of the second fraction. So the first fraction, the 4a plus 4, I highlighted that piece because you can factor it. Take a GCF of 4 out, so it's 4 parentheses a plus 1. The second fraction, once you flip it, you can't factor anything there. So then start looking for like factors. So the a plus 1s at the top and the bottom cross away. Nothing else is alike. So you only have an a minus 2 at the top with a 4 and then parentheses a plus 5 next to it. The next example underneath, again, keep, change, flip, multiply by the reciprocal. The trinomial in the first denominator can factor into y minus 8 and y minus 2. And once you take the reciprocal of the second one, that denominator, y squared minus 9, is a difference of squares. So again, you need to be able to recognize that and know that that factors into y minus 3 and y plus 3. So now that everything's factored, look for common factors that divide out. So the y plus 3's are gone. The y minus 3's are gone, and the y minus 8's are gone. So technically, we have crossed off everything at the numerator. So you have to put a 1 there just as a placeholder. And then you have the y minus 2 factor and the y plus 3 factor at the bottom. Alright, so here's a lot more examples. I won't talk through all of them because they're very, very similar. Same process. Keep the first fraction, multiply by the reciprocal of the second one. Look for GCFs, look for trinomials, difference of squares. I highlighted some of the parts that can factor in some of these questions. Some other types of problems you may see later is, notice on these, it all uses the division sign with the 2 dots in the center. If you look at some of these examples, this is what's called a complex fraction. So this means it's like a fraction divided by another fraction, so it makes like a big fraction. Just know that the middle one there, you can kind of see it highlighted in 3B here. That middle fraction bar can just be replaced with a regular division sign, so that I can still multiply by the reciprocal of the one that's underneath it, and kind of do the similar process as the other questions. So you can see over here, I'll talk through example B on the right side. I had that top fraction times the reciprocal of the bottom, and I had 2 trinomials in the first one that you can factor. So that was n minus 2 and n plus 9 over n minus 1 and n minus 1. And then the difference of squares there, n squared minus 81 becomes n plus 9, n minus 9. And then look for like factors that divide out. So the n plus 9s go away, the n minus 1s go away. So up there, that's in the box, is your final answer, n minus 2 over n minus 9 and n minus 1. So again, the important thing here is when you're doing the 6 questions in the homework in the Google Forms, rewrite it, take a piece of scratch paper, keep, change, flip, factor everything that's needed, and cross off common factors.